And welcome back, class. And guess what? Today is the last lecture video of not only chapter 12, but for the entire course for the semester. So congratulations for making it this far, and let's get to it and finish up strong. Okay, so now we're finally going to get to regression, correlation, scatter plots. So this is the last section, and we're going to talk about scatter plots, correlation, and regression lines. So we're going to talk about how to make a scatter plot for a table of data items, how to interpret information given in a scatter plot, how to compute the correlation coefficient, how to write the equation of a regression line and what it is used for, and then we're going to use a sample's correlation coefficient to determine whether there is a correlation in the population or not. So now a scatter plot is a collection of data points, one data point per person or object. Now, it can be used to determine whether two quantities are related, or two variables rather, are related. Correlation means there's a clear relationship between two variables, okay? Used to determine if there is a relationship between two variables, and if so, the strength and the direction of the relationship. Now, we're going to talk about linear correlation for the most part, okay? But there's also nonlinear correlation. Okay, so now in this scatter plot, this scatter plot shows the downward trend among data points with some exceptions, okay? So people with increased education tend to have a lower score on a test measuring prejudice, okay? So score on a test measuring prejudice. So this is some sort of diagnostic test. And so we have years of education. So as years of education increases, the score on this test seems to go down. Okay, so there seems to be a relationship between these two variables. Okay, now although the scatter plot shows a correlation between education and prejudice, we cannot conclude that increased education causes a person's level of prejudice to decrease. So we can't say that there's a cause-effect relationship here. We can say that there's a relationship, but we can't say that it's a cause-effect relationship. So one, the correlation could just simply be a coincidence. It could be a fluke. Two, education usually involves classrooms with a variety of different kinds of people. So increased exposure to diversity in the classroom might be an underlying cause. So there might be another cause that's causing both of these, right? Or not causing both of them, but be causing the decrease in the prejudice. Okay, so it might not be the education itself. Okay, now three, education requires people to look at new ideas and see things from different ways. Thus, education causes one to be more tolerant and less prejudiced. So there could be a cause-effect relationship, but we can't say there is one by just looking at a scatter plot. So now regression line. A regression line is a line that best fits the data points in a scatter plot. Okay, so there's many different lines we could draw, but we want the best fit line. Okay, so how do we get the best fit line? Well, one way of doing it is using what we're going to use as the least squares regression line. Okay, but we'll get there in a moment. Okay, now if we see a pattern, let's say we see a linear pattern in a scatter plot. Well, the next logical step is to calculate a number to represent that relationship, that correlation, quantitatively. Okay, so the correlation coefficient, which we designate as R, is a measure of how strong and the direction of that relationship is. Okay, now R only measures linear relationship, so it does not say anything about nonlinear relationships. Okay, it's only a measurement of linear relationships. Okay, so it'll tell you how strong it is and what direction it's going. Okay, so now positively correlated means that as one variable increases, so does the other. So whatever direction one goes, the other one tends to go as well. So they change together. So positive means as one variable changes, either positive, so does the other one. If it changes negative, if it decreases, then so does the other one. Negative correlation means that as one variable tends to increase, the other variable tends to decrease and vice versa. Okay, so that's what we call negatively correlated variables. Now, a perfect positive correlation would be a straight line, right? So that would be a straight line, all the dots in a perfect line that rises from as you read the graph from left to right. A perfect negative correlation would be like a perfect line of dots from left to right going down. Okay, we very rarely see this. In fact, the only time you see this type of relationship is mathematical formulas. Okay, so if you look at these scatter plots, we could look at this one and see this is a perfect positive correlation. So it'll have an R value of 1. This one would be a strong positive correlation, so it's not quite a straight line, a perfect line, but it's pretty close. So this would be a strong positive correlation, and we would say an R value approximately around like 0.8. Moderate to weak positive would be something that would be a little bit more wide, right? So it's not quite as narrow. And so this would, let's say, around a 0.3 for an R value. And then, of course, no correlation, which just looks like a cloud of dots, no discernible pattern at all. This would be basically a correlation of 0 with no correlation. And then the same sort of thing we can see with negative correlations. So this would be a moderate, right? Moderate to weak negative correlation. So look, negative 0.3 versus 0.3. Then we've got a strong negative correlation. So you're looking at something that is like a negative 0.8. So this would be a strong negative correlation. And then, of course, a perfect negative correlation is something that's really just a straight line of dots. And so that would have a correlation R value of -1. So now notice that the range of R values goes from -1 to +1. And it's a continuous range. So any R value is going to go from -1 to 1. Okay, so if it's positive, then it's going to be going upwards from left to right. If it's negative, then you've got a negative correlation going, and it goes down from left to right. Okay, and then anything close to 0 is either weak to no correlation. Anything around 3, 4, 2 is weak, moderate to weak. And then you've got anything, well, 5 would be probably moderate, 6 moderate, and then you've got around 7, 8, 9 would be strong. Again, these are not written in stone, but it gives you a general idea of how we rate these. Now here is the formula used to calculate the correlation coefficient. It is a huge beast. Okay, so you need to know all of these different pieces. Okay, so what do you need? You need to know the sample size. You need to know the products of x and y. You need to know x. You need to have the values of the y. And then you're going to have the values of x squared and the values of y squared. Okay, and so we can get all of these by using a table of values to build this formula. Okay, so these are all of the things that we need. Okay, so now these are all of the things that we're going to need. Okay, now notice that n is the number of pairs of xy pairs. So it's the sample size because all xy pairs are normally, they're going to be the same. So, but to be concise, n represents the number of pairs of data points. Okay, so we're going to need to know the sum of x, the sum of y, the sum of the products of x and y, the sum of the x values squared, the sum of the squared y values, and then of course sum of x quantity squared, and then sum of y. quantity squared. So if we have this data set, okay, so we have the data involving the number of years in school completed by 10 randomly selected people and their scores on the test measuring prejudice, Y. So X represents the number of years in school, right? Number of years of education, and Y represents their test score. Now we want to determine the correlation coefficient between years of education and their scores on the test. So here's how we build it. So we write down the values of X, we write down the values of Y, and we sum the values of X, and we sum this column. We get the values of Y, and then what we do is we then multiply these two numbers. So we multiply across, and we get the product of X and Y. So we multiply X and Y across, and so we're going to get all of these products, and then we sum that column, and we get the sum of X, Y, and then we square the X's, so we take all of the values in this column here and we square them. So 12 squared is 144, 5 squared is 25, 14 squared is 196, then 169, and so on and so forth. And so then we sum up all those numbers and we get this value, and then we do the same thing for Y squared. We get all of these values. And then the only thing we need to do is take this value and square it. And then once we have that, we get all of the values we need, which is right here. And so we plug everything into this formula, and then we, with the use of our calculator, we just calculate the value, and we get negative 0.92. So it seems like there's a strong negative correlation between years of education and your score on the prejudice test. Now, if there is a significant correlation, then the next step is we want to find that line that best models the data. And so in this case, again, because we're dealing with linear models, we're going to use the y equals mx plus b. Now, in this case here, the slope is going to be given by this formula, and b is going to be given by this formula. Okay, now, I'm going to give you also some other better formula, easier formulas to remember. This is also equal, instead of doing this, this is also equal to R times the standard deviation of X, or excuse me, Y's, the standard deviation of Y's divided by the standard deviation of the X values. Okay, and then this one here, you can actually see this is just Y bar, and this is actually M times X bar. So you could split this up into two fractions, and B is actually just equal to the mean of the Y's minus the slope M times the mean of the X's. So Y bar minus M times X bar. Okay, so you can rewrite this one as this, and this one is also, now I don't know if this is any simpler than just using this, because you're going to already have these values from the table, so you could just plug and chug into here, and then of course you can get Y bar and X bar easily, and then you already have the slope from this calculation here. So again, just make sure you're practicing with these. So now to find the regression line, we need the slope and the y-intercept using those formulas. So if we use the information from the example that we just did, we find that the slope is negative 0.69. And then if we use the formula for the y-intercept, we find that the y-intercept is approximately 11.05. And so we always want to make sure that we're doing at least 2 decimal places. Now, no more than 3 decimal places, but no less than 2 for your equation line. I will tell you how many decimal places I want. So they went to 2 decimal places on both of these, okay, which is fine. Okay, now, in a previous example, we computed that the R value was 0.92 with n equal to 10. Now, we don't know if that's significant. Okay, it looks strong, right? It's definitely a high negative correlation. It looks like it's a strong negative correlation between education and prejudice. But can we conclude that there actually is a negative correlation between education and prejudice in the population? In other words, is R significant? Okay, is there truly a correlation or not? So what we do is we take the absolute value of our R value. So in this case, it'll give us 0.92. Now, what we do is then we use what we call a correlation table. And so what we do is we use our n value, the sample size, and in this case here, we want to use usually either 0.05, and this is a significance level. Okay, so all you have to do is know that this is a significance level, 0.05 or 0.01. And so how we determine significance is this. We take our R value, our positive R value, and if our correlation coefficient is bigger than the critical value on the table, which are these are the critical values that we're looking up. If our correlation coefficient that we calculated is bigger than the critical value, then our correlation is significant. Okay, so in this case here, if we look at 0.92, we get these two critical values. So notice that our R value is bigger than both of them. So it doesn't matter which one we use, it's going to be significant. So that means that there is a real correlation between the two. Okay, and then if there is, now that we've determined that there is a significant correlation, now we can go and do the regression. If there was no significant correlation, there would be no reason to do the regression analysis and get the regression line. Okay, we would just use the averages. Okay, so again, make sure you practice, practice, practice. Okay, again, do the suggested homework, ask questions, come prepared to class, and let's nail this. Okay, talk to you later. Have a good day.